Hey team, this is Hector, and today we're going to cover link list insertions. So we're going to continue where we left off in the last video in our link list intro video, where we created our node data structure. And today we're going to create a link list data structure to control our node list. So we're going to create a link list class. I'm going to call this link list. This linked list is going to have a private set called head. It's going to be of type optional node. It's also going to have a private set of type tail, which is going to keep track of the last node in the list. This is going to be of type node. And we also want to track the count of the list. So we're just going to say count, and this is going to be of type. Actually, we're going to initialize this to 0. Okay. And the reason that I'm using a private set is because I want to have access to the head and the tail, but I don't want to be able to modify it from outside the class. So then when we declare a variable to be a private set, it's only accessible within the class itself. Okay, so let's get started. The next thing I want to do is I want to initialize with this node that we created from the last video. But then I also want to be able to track the tail and the count when we initialize. So let's do that right now. So we're going to initialize with a list, and we're going to call this is going to be the type optional node. And right away, we're going to set our head to the list. Okay. Next thing we have to do is we need to iterate through our list so we can grab the tail and the count. So let's do that. So actually, I want to create a copy of the head. So we're going to say head copy. I'm going to call this head copy equals head. And now let's iterate through our head. The reason why we're creating a copy of a head is so we have a reference to it after we iterate through the list. That way we can come back and set our head to the head copy, which is the start of the linked list. So let's start by iterating our head. We're going to say self head dot next does not equal nil. Then we're going to just keep iterating through, and we're going to say self head equals. My typing is a little bad right now. So head dot next, and we also want to keep track of the count, right? So we can say self count equals 1. Oops, misspelled that. Okay. The reason why we're saying next is because we don't want we don't want to iterate all the way through. We just want to iterate to the last node. So we want to keep track of when the next is nil. That way we have the last node is head. So now we just say self tail equals self head, because that would be the last node. And now you can say self head equals head copy, which will be the beginning of the linked list. And we also need to increase the count by 1 because we're adding another node. We're actually weren't able to catch the last node on this count, so let's just do that here. Okay, so there we got it. So now let's initialize this list. So let's just say, let's do it down here. So we're going to say, make it into a constant. Let's say linked list equals linked list of type. And then we're going to input the list that we've created beforehand, which is a list node. One other thing I want to do before we start checking if this works is I want to put this into a function. This little code that we wrote before. So we're going to call this list to array. It's not going to take any parameters. It's going to return a integer array, and then let's just move this whole thing over. And then we just got to change a couple things. Do have to create another copy of the head. Of our head copy equals head, and you need to make sure this is optional as well. So let's say node optional, and let's just iterate through the copy this time. So we're going to say, well, head copy, and we're going to change this to head copy. Same thing out here. Copy, and that should be it. You just need to do a return of the array. Perfect. Let's this up a little bit so it's more legible. Perfect. All right. So now that we have, we've actually initialized there's our list. It's complaining here because it was not changed, so it wants us to create a constant. Okay. So let's run that. No errors, which is good. Now let's actually check the values of our linked list head and our linked list tail and our linked list count. So let's check those values. Yes, so we have our head is 1, our tail is 4, and we do have a count of 4, which is correct, right? Because we have, here you can see we've created a node with 4 links, 1, 2, 3, 4. So it's correct. And we can also use our helper function up there, list to array, so we can look at our array as well, make sure that we have the correct. Oh, and it's running into an infinite loop, which is not good. Oh, I see what we did. Okay. So this needs to be head copy as well. And this needs to be a variable. Okay. Perfect. So we have 1, 2, 3, 4, which is our linked list that we created. Now let's get into insertion. So we're going to start with push. You can see in the diagram here, we're adding a new node to the beginning of the list. And we do that by just pointing the new node to the beginning of the head, right? So we point the new node to the head, right? So let's do that. So we're going to say push, and this function is going to take in a node, right? A node, and it's not going to return anything. So how do we do this? So what we do is we actually need to create a copy of the new node. So we're going to say new node equals, let's make this into an optional node. Actually, we can do that up here. So new node equals a node, right? So you can see this is going to be optional. See that right here. And now all we need to do is say node, new node, next equals self head, right? And then now what we need to do is we need to declare our head to become the new node. And it's complaining because we haven't changed this value. Fine, we'll create it into a constant. Okay. Now let's see if it works. So what we're going to do is we're going to comment this out, and we're going to say link list push node, and we're just going to leave it blank. We recall our node with no initializer just creates the 0 value. So we're going to just want it to input the 0 at the beginning of the count. All right, so let's run it. See if it crashes, no crashes. Let's reutilize our linked list array, linked list to array here. And let's see if it actually input the 0 beginning, which it did. Now we have 0, 1, 2, 3, 4. And the last thing we got to do is increase the count by 1. So the count has to be 5 now. So let's just reuse this. And the count should be 5. And it's 4. 1, 2, oops. Did not increment. What's wrong with me? Okay. So it's 5. Great, perfect. So as you can see, all we did is we created a new node. We pointed that new node to the head, and then we created the new node into the head. That's all we did. Yeah, so let's push. So the next insertion method I want to use is add. Right, here's a diagram for add, where you're just going to add the new node to the end. You can see here that the last node is D, and it's pointing to null. And what we want to do is actually point it to the new node, and the new node will point to null, in our case. Okay, so let's get started, and this add method will take a node, type node, optional. It's not going to return anything. First thing we want to do is check if the head is nil, because it could be nil. And if it's nil, what we want to do is we just want to set the head and the tail to the new node. So we'll say self head equals node, and self tail equals node. Perfect. Now, if the head is not nil, all we gotta say is we gotta grab the tail, and we would need to modify the next, right? The next variable, right? Which our next would be it's a node, or it could be a node, or it could be nil, right? So we don't want it to be nil anymore, so we're gonna say self next equals node. Oops, equals node, lowercase, right? And our self, and then now we need to reset our tail. So our self tail now be equal to self tail. So our self tail will be equal to self tail next. That should do it. So this is pretty much saying this. So this will be our tail, right? So then we're declaring that our next is now linked to this, right? So our next is now linked to the new node, which will be here. And so we're saying, so the new tail is going to be the current tail's next, which will be this right here, this value right here. And yeah, so that'll be our tail. So let's see if it works. We're going to reutilize these two here, and this reminds me that we need to increment by 1. So we're going to say count plus equals 1. We're going to say link list add. We're going to create a new node. Let's call this 5. Value 5. And let's run. So after running the code, we can see that we were able to insert the last node at the end until here, it's 5. Now the count has increased to 6. So that's add. Now we want to talk about inserting after an index. So here's a diagram for inserting after an index. So we want to insert after index 1. We need to sever the tie to the next node, point that current index to the new node, and the new node will point to the next node shown here. So let's get started on that. So we're going to call this func insert at index. It's going to take integer as index. Now we're going to take another node, optional node. It's not going to return anything. So the first thing that I want to do is create a copy of the head. So we have access to the head. It's head copy equals head. So head. Now we want to create a while loop to loop through the head itself. So we're going to say self head. While self head does not equal nil, we're going to increment. Actually, we're going to first check. We need to also keep track of our index. So we're just going to create an index called I, make that equal to 0. And we will check if I equals index. If I equals index, and this is where we want to sever the tie. Else we'll just keep looping through. We'll keep iterating through the linked list. So we can say link self head equals head next. And then we also want to increment the count. We can say I plus equals 1. So pretty much once we're at the index, we want to insert our new node, right? So first we need to create a copy of our next node. So we need to keep track of this node here. So we'll do that by saying let next node equals self head next. And now we want to, on our current node, which will be B, right? We want this to point to our new node, right? And we're already keeping track of this node here, right? So the way we do that is by saying self head next equals node, which will be this value here. So pretty much what we're doing is we're just the next is think of the next as the arrow. So now the arrow is pointing to the new node. So now that the arrow is pointing to the new node, we need to say self head next next equals next node. Which is what this is saying is what this last line is saying is pretty much this. So this is the first next, and this is the second next, right? And this the second next is going to point to the next node, which will be this one. Okay, that way we're relinking everything together. Okay, and that should be it for this one. We also want to reset our head. So before we leave, we want to reset our head. is saying self head equals head copy. Again, we keep track of the head by just making a copy of it, right? And then we also want to increment our count by 1. So self count plus equals 1. And I think that's, oh, this is inside the while loop, so we need to make sure that this is outside the while loop. And we can just move that down here. Also, I want to do one last check. So I want to say if you want to check that the index is below or over the current count, so below being under 0 or over the counts or over the count, right? So we want to say index is less than or equal to 0. Actually, we want to say if index is greater or equal to 0, and if index, oops, and index is less than or equal to self count, right? Or else we're going to get errors if we input the wrong index. And then we want to move that all into the if statement. That way, this insertion method only runs if the index makes sense. Okay, so that looks like that's it. We're going to just reuse this whole thing here. Actually, we don't need this. We're just gonna reuse this. Add it here, and we're just gonna insert. We're gonna use the insert method. We're gonna insert it at, let's say, at index 2. And this node is in the value 100, so we can see it clearly. And let's run it. Let's see if it works. And we got an infinite loop again. Okay, we need to break out. So we need to break out of our while loop, or else it's just going to keep looping. So once we find our index and we're done resetting our list nodes, we need to just break out of the loop, or else it's just going to do an endless loop. And there we go. So now we have our 0, 1, 2 index, and then we have our 0 here. Let's open this up a little bit. And here we have 3, 4, 5, which now the count is 7. And yeah, it looks like we did it. Awesome. So this is our linked list data structure, which allows us to control our linked list. And we also created a node that allows us to structure the node itself, right? So that's it for today. Keep coding and stay motivated. And please like and subscribe. See you next time.